So, good afternoon, everyone. Can you hear me? Fine? Yeah, sure. So, my name is Jeremy Matos. I'm French, but I would do this talk in English because it was announced in English. Sorry for people who wanted French. I used to be a developer, and about 10 years ago, I started doing like 100% AppSec. I used to have my own company. So if you search on Google securing apps, you find like several talks about it. And I joined GitLab 6 months ago, so I was really happy to do so. I'm also co-chapter leader at OWASP Geneva, and I used to organize a security conference in Switzerland. So we are going to talk about management of front-end dependencies. So basically in your web application, when you include third-party JavaScripts. From what I've seen in many organizations, when they care about application security, which is not that often, for them, application security is really, well, you have to do stuff on the backend side. Because why? Well, input validation is, because of that, you get XSS and all this kind of stuff. Well, the fix is you have to do something well server side. When you have permission issues, well, you have to fix it server side because otherwise people can cheat. When you have SQL injection issues, well, you have to fix it server side because you have to do prepared statements. So that's for, let's say, the fixing part. As a security analyst also, I admit personally, when you have to review thousands of lines of code, you tend to ignore everything that's happened in the front-end layer. Everything that's UI code, you say, well, yeah, maybe there are dirty things there, but do you really care? Because what's important is what is done in the backend. Because if everything has been implemented in the backend correctly, all the checks, we should be fine. And I think that, we get this impression that, only backend security matters because, it's, well, you shall never trust what happens and what comes from the client because everything can be manipulated. So people really tend to believe that everything should be addressed on the back end, but it's wrong because browsers have implemented a really complex but strong web security model. So you cannot do anything from, let's say, your website A. You cannot do whatever you want, and the browser has many controls. And on top of that now, so if you are building a web application and you want some nice UI, you have to include third-party dependencies. So you need JavaScript libraries, you need JavaScript frameworks, and you also need content delivery networks to cache those JavaScript so that the first time the user comes, it doesn't take ages to load like maybe 5 megabytes of JavaScript. So for me, what it means that front-end security is getting a bigger and bigger concern, and we tend to forget it. And we will see why with two proven cases, what can go wrong if you don't really care about it. And sometimes I have questions, I say, well, my organization, this cannot happen because we have a full stack, we have full stack developer or full stack team. Yeah, it doesn't mean that you know front-end security. Doesn't mean that you do everything, doesn't mean that you do everything well. So still apply for you if you are a full stack developer. So now let's discuss with two real hacking cases, Ticketmaster and British Airways, and see what went wrong and how it could have been improved. Because many times in security conference, especially when there is a CTF, you have brilliant people that are able to break stuff, to hack into it. But as an engineer, as a former developer, for me, in the end, you get like a pessimistic feeling at the end of those conferences because, well, basically everyone can break everything. And then what do we do with that? How do we fix it? So we will see some solutions. So I don't claim we will, after that you will be able to fix everything, but at least have some knowledge of how you can improve it and improve it efficiently. At the end, we'll have a Q&A session, and I'd be happy to discuss openly with you how you manage it and maybe you have good ideas to share. It's also something that for me is really missing in the security industry, is really sharing your best practices concerning application security. There is not really a good book on what you should do. You just have many talks that say, well, what you should not do. So let's discuss in the end and see if we can share best practices around it. So first case, Ticketmaster. Last year, they had to disclose in June that credit card data of around 40,000 users had been leaked, mostly UK customers. And it was not clear in the communication, and maybe because it was not clear from them, if the leaks happened in June or if it started in February. So they did a forensic study, and conclusions were really interesting because Ticketmaster database was not stolen. In fact, Ticketmaster was not hacked directly, and the payment processor was not hacked. So they had credit card data in the wild, but not coming from their database, not coming from the payment processor. But the conclusion is that, yeah, it's been stolen by a JavaScript that was hosted by a third party. So what's really interesting there is that, well, Ticketmaster, of course, they have to handle credit card data, so they are PCI DSS compliant. So they show and they have to do good security to achieve this certification. But what we will see is totally out of scope of this certification because it's something that the regulators have not thought about. So let's see more details. So there is a third party in the loop. The third party is called Inventa. I'm not blaming them. Huh? So it's a Spanish company. They are doing AI stuff for marketing. And what they did, they made a custom JavaScript specifically for Ticketmaster because they wanted to, don't know, get whatever marketing data for Ticketmaster, and Ticketmaster believed that this company could provide them useful insight. And in the end, what happened is that this JavaScript, tailor-made for Ticketmaster, but not written by Ticketmaster, was directly hosted, well, not hosted, but included in Ticketmaster payment page. But Ibenta did not knew about it. So somehow they say, and when you look at all the responses and all that, and they say, Ibenta say, yeah, you know, somehow we delivered a JavaScript to you, but it was some kind of POC. Of course, you should never have put it in production, and even less in a payment page. Otherwise, we would have told you why you shouldn't have done that. So that was really, yeah, let's say the responsibilities were blurry. But what's really interesting is in detail the attack. So there is a Magic Card hacking group. Now they have dozens of cases documented on them, but those one, the two I'm showing to you is, I think, the easiest one and the most impactful. So what they did, in fact, end of 2016, so 1.5 years ago, they breached into Inventa, which is some kind of startup doing AI for marketing and all that. So I guess their defenses are clearly not to the level of Ticketmaster. So they breached them, and what they did, so basically they just have connection to the server, and then at some point, when they saw that Ticketmaster was including this JavaScript in their payment page, one day they decide to edit the script and to add just few JavaScript lines that is doing what? Just when you type a credit card number, it takes it and it sends it via Ajax to some web domain called webfots.me, so some kind of wrong web domain. So it's just basically it's a keylogger. They added a keylogger functionality in this third-party JavaScript. And they didn't try to hide it well or not. So if you're really interested in that, we will share the slide, of course, and you have the detailed analysis by risk IQ here. But in the end, it's so simple. You just need to copy paste a few lines of code in a JavaScript, and then that's it. So you have a provider of service that is PCI DSS certified, but all the data is leaked. And then people told me, yeah, but how come Ticketmaster couldn't detect it? Don't they have data leak prevention? Don't they have IDS and all that? Well, nothing is reaching the Ticketmaster servers. Nothing happened. Ticketmaster cannot see anything because it's just happening in the browsers of the users. So as soon as you're typing something in your browser, an extra request goes to eBenta, and then, well, not directly eBenta, but because of eBenta, it goes directly to the hackers. So Ticketmaster cannot see anything about it. So before going further, I'd just like to talk about the same origin policy, because it's something that's not so clear how the browser should protect from such attacks. So the basic, so when you design a web page, you can include static resources from any other domain. So you are ticketmaster.com, you can include a JavaScript from google.com, a picture, whatever, it's going to work, because by design, you can include external resources, but it's supposed to be called static. So this is for the loading. And then there is somehow for the execution of this JavaScript code. So there goes the same origin policy where it says that the JavaScript that has been loaded can only access to the page content only if it has been loaded from the same origin. So basically it means that if you are ticketmaster.com, from ticketmaster.com, you say, yeah, include something from google.com, then this script from google.com is going to be able to see all the page content. But now let's say you are evil.com and you try to somehow read the page of ticketmaster.com, you will not be able to do it because the browser will say, well, no, sorry, evil.com has not been loaded from ticketmaster.com, so I don't give the permission to read it. And just a remark, you cannot steal cookies if they are protected by the HTTP only headers, which means that even if we are in the context of the same origin policy, this script from google.com will never be able to read the cookies ticketmaster.com. So now solutions. It's something that, in fact, rather common for payment page or for some pages where you have really sensitive information. Well, first thing is, well, don't use any third-party JavaScript for your payment pages. So that's why you can get, like really ugly payment page where you enter your credit card data. Like I don't want to mention the one of eBay or whatever, but they don't look good, especially on mobile. It's because of that. So in fact, they have maybe a nice UI in the website, but then you get redirected to a payment page, and this payment page is mostly static and I don't have any like fancy UI and all that. So that's why. Some people ask me, well, you told me about same origin policy, but how can people then, because of it, how you can exfiltrate data? Because you're not supposed to be able to do anything. Yeah, well, to exfiltrate data, in fact, as long as your JavaScript is able to run, that's super easy, because you just have, for example, to request a picture from whatever URL. So, for example, malicious.com/image1, and then the server that you control that's under malicious.com will not have a picture under this URL, but in the logs, you will be able to find some data and whatever. So that's easy. So, well, first solution is, well, have ugly payment pages, and then maybe you can survive with it. Second option would be to use an iframe with a sandbox attribute. So with it, in fact, let's say your sensitive content, you put it in an iframe, and this iframe, you give sandbox instruction that say, well, from this iframe, the JavaScript cannot do anything, the JavaScript cannot reach that or whatever. So it allows you to have, let's say, a full page that's somehow not too ugly and just the payment fields that are protected. Another solution could be to use a sub-resource integrity called SRI from W3C. So what it does is, in fact, the first time you're developing, so you say, yeah, I want to include this script, and you compute a hash of this script, and then you store the hash in your web page. And then when the browser loads the external JavaScript, it will compare it, and if it does not match, it will say, well, I won't load it. So for example, for Ticketmaster, it would have worked because they would have computed the hash of the Inventa script at the beginning, and then when MagiCard changes it, well, the browser wouldn't have loaded it, and then nothing would have happened. But it's a bit heavy. We will discuss after on the operational challenges. D, I talked a little, so you can still use JavaScript, but yeah, really keep pages as simple as possible. So for me, it's a bit like a nonsense to try to do AI on a payment page because yeah, what do you want to do with it really? You want to make statistic on the expiration date or whatever. So I don't see it. So personally, I don't know why it has been included. Yeah, maybe the only valid reason is well they included it in every page, and then it arrived there. Otherwise, yeah, doesn't really make sense. And last but not least, there is something strong now called content security policy, which is some kind of much better sandboxing than iframe. We will discuss later with a second example of what can go wrong and how to protect from it. So the first case was Ticketmaster, and somehow, well, a third party was leaked, and because of that, all this credit card data was stolen. A few months after, British Airways had something that looked similar, 10 times more user, but yeah, 3 months after. And it was this time it was personal information and credit card data and stolen from the website and also the web application. Again, the forensic study concluded that, well, British Airways database was not leaked and that it was not an issue with their payment processor. But this time it was a JavaScript hosted directly by British Airways. So Modernizer, which is some kind of UI JavaScript library. So they downloaded it, they put it in their server. So somehow they should be in better control because yeah, they are not loading it from a third-party domain. But what did the MagiCard hacking group did? Well, they hacked the British Airways web server on August 21st, so they know it now because it's happening in their infrastructure. So British Airways can know better what's happening. And again, they added this kind of same line. So they added a card schema feature directly in this library. Of course, I guess if I ask you the question, when you include JavaScript libraries that are thousands of lines, yeah, do you read them before including them? No, of course, no. So it's what they did. So that this one is really nasty. So they enter the web server and they just say, yeah, let's just change the UI and let's just change the source code of a third-party library, and we're sure nobody's going to have a look at it. And then what happened? Well, in the end, it's exactly the same impact that for Ticketmaster. As soon as someone types personal information or credit card data, then they steal this data directly from the browser and they send it to a fake domain, which again the name is like interesting, which is baways.com. So it really looks like it's a domain from British Airways. So even if you're paranoid and you use no script extension and that, you see, yeah, baways.com, yeah, should be British Airways. So I would authorize it. So it's kind of well done. So the detailed report is really interesting to know how they try to stay undercover for a long time. And then there's a question, but what happened about the mobile app? It's something totally different because you're not supposed to have JavaScript and it's supposed to be an app because you download the app from the Play Store or from iOS Marketplace. Well, in fact, they had a good idea, well, because they wanted to save on development cost. All the pages that were handling personal data, credit card data, and all that, in fact, they were using a web view, so they were reusing all the pages from the web server that was leaked. And I don't even know if Magic Art knew it when they did the trick, but yeah. So in the end, all the customers were impacted because of that. So what can we do with that? And now it's really becoming a tough question. Because of course, yeah, when we say, yeah, don't host third-party JavaScript, well, now we are on the same domain. So, well, somehow they have their web server hacked, so it should feel like it's game over, but we still may find some solution. Well, of course, if they try to use iframe sandboxing, well, it's useless because if they can edit a JavaScript, they can also go to the web page and say, yeah, just delete this sandbox attribute, sub-resource integrity, same stuff. Just remove this attribute and then that's over. Of course, if the goal was to say, okay, now we keep the payment page really super simple and all that, well, they are free to include whatever extra stuff they want so that they can have this stealing functionality in it. Of course, if it's getting too big, it's going to be visible. If, let's say, the payment page becomes pink and all that, all the users will see that something is weird. But it's still difficult to, yeah. If you're, let's say, discrete, then it's going to be hard to detect it for British Airways. So what do we have left now? What can we do in this case? Except, yeah, be sure that your web server is not hacked. So here comes, we will discuss more about content security policy. So what it does, in fact, it allows to whitelist everything that is authorized from the web page. So from where can you load pictures? From where can you load scripts? Can you load fonts? Which kind of JavaScript methods are allowed to run and all that? So again, you can tell me, well, okay, this looks good, this content security policy, but they can just change because they're on the server, the web server, they can just change it and remove it and whatever. Yes and no. It really depends on the web infrastructure because many times you have a reverse proxy, an Nginx, for example, in front of your web application. And generally, it's not managed by the same people. So it's likely that if your web server gets hacked, maybe your Nginx in front of it is not hacked. So if you set up all the content security policy configuration in your Nginx and not directly in your web server, then somehow, well, you have shared responsibilities and you can hope to be protected from that. If it's not the case, then there is one last solution that I thought about, maybe you have other ideas, is, well, you have to make things difficult for Magic Art. So you're just adding 3 lines of JavaScript is too easy. So what you have to do is you have to obfuscate the JavaScript and add tampering detection code inside the JavaScript so that if they try to play with it, they just change 1 line. So JavaScript is not going to work and it can alert the owners and all that. So I'm not doing any advertisement there, but some companies try to do it. For example, one is called JScrambler. So it takes your clear text JavaScript and it gets something super heavy, dirty, and all that. And it should protect from people easily modifying, tampering those JavaScript. And I'm open afterwards at the end of this talk. So if you have any other ideas, I would like to hear them. Okay, so now you say, okay, that's fine. So yeah, maybe we should take care about those third-party dependencies. We should do something, but how much work for it? Because you know, when you're developing a web application, you have to, yeah, you have to deliver everything for your sprint. You have lots of tasks to do. So you can't say to your manager, say, yeah, well, the feature is 2 days, but then I need 3 weeks to secure it. I say, well, come on, you're front-end developer. You don't need to do security. You're not backend. So I just put some open questions here. So first question is well, how do you make sure the JavaScript you download is clean? So that's not easy, but most of the time you download it from like a famous repository, GitLab. So it should be fine. So, but somehow you have to be careful from where you download it from. But what I'm more worried about in practice for having, for helping companies set up that is, there is a performance impact at some point for the end user. Well, if we say don't load JavaScript from third-party domains, the first time you connect to the page, you have to load this JavaScript. Sometimes the JavaScript size are crazy. Some scripts are like 2 megabytes. So if you have a slow connection and you are not using CDN, it's going to take like maybe 10, 20 seconds to load. So you have to be careful about it. And maybe it's also a good reason not to include anything that you think might be helpful. But there's also a performance impact for the dev team. You know, when what people do sometimes, because those JavaScripts are crazy heavy, you take all of them and you pack them and you try to reduce them and all that. So you have a complex build chain because of it. And this build chain may be broken if you want to add all those extra steps of, like, you know, you want to compute a hash, but if your build chain is taking several scripts and then packing them, and somehow you have to add the hash on the pack version and not on the clear version. So there are operational challenges there. And what I saw in practice, people say, yeah, we will handle this issue because this is really a big concern. We really care about the security of user data. So we compute those hashes and we do whatever we want to do there. And then comes, 3 months after, there's a CVE published on this JavaScript library because it can leak data if you provide like some crazy Unicode input or whatever. And then they say, it's been too much work. We are not going to update because we have to recompute the hash and the deployment process is too complex and all that. We did it once and we stay to the old version because otherwise I'm not sure what's going to be the name in the content delivery network. So I'm not going to upgrade. So please, if you just have to do something, please update before. And if you can only do something, just update and then forget what I said about the first point. Better have up-to-date dependencies, it should be better. Then now you say, okay, now I want to do things well. I understand what I'm doing. I will do updates when I need to do updates. I'm okay to have some impact on it because I want to protect my users. Then comes to the point you say, well, maybe content security policy is the best thing you can do. So in practice, what it means, it's really for me, it's an iPhone sandbox on steroids. So you can configure everything you want with it. It's really difficult to configure well. So it's Google who really pushed this standard. And why I discussed with some guys from Google that worked on it, and they had so many issues in Gmail with XSS and all that, because you can include whatever crap you want in Gmail. So it was really, really hard for them on the backend part and to filter everything. So they say, wow, now we are convinced we will never be able to catch 100% of the XSS stuff in Gmail. So what we do, we would add a browser protection. So let's do it in Chrome and then let's push the standard. And then let's blame the other browsers if they don't implement it. And it worked well up to the point when it was only used by Google. And then maybe 2-3 years after, they realized that it was crazy complex. And then they made a survey and they find out that 95% of the CSP configurations were wrong and were protecting from nothing. And this included like some amateur website like facebook.com or things like that. So then somehow they change their mind and they try to version 3 to have something easier. But yet for debugging, debugging is hard. And the only trick that was proposed by Google was the notion of report URI. So what it does is each time, so the browser will load this policy, and then when something happens on the page, if we check if it's compliant with the policy, and if it's not, by default, it's going to block it. If you go to the developer console, you will see alerts for it. But then you can configure the report URL, which will call an API at your website or whatever, so that you get information that someone is either injecting strange data on your website, or that, well, maybe something you've been too tight in the configuration policy and then something is not working. So it's really good first for debugging while you're in testing phase. So you can have it on in report only mode. So what you do in practice, yeah, you set up maybe some tight policy. You run all your integration tests because you have integration tests and you have good integration tests. And then you only have to go through the report and see what you have to fine tune there. And then in production mode, that's also really helpful. So you are in blocking mode, but you say that it's blocking, but each time there's a violation, your API is contacted. And so you have an idea of the payload people are playing with. So at the beginning, it sounds like a good idea, but let's say if you're GitLab.com, you don't want to receive like thousands of payloads per day because you cannot manage anything with it. So what we are using at GitLab, so we are using content security policy because yeah, a bit like Gmail. Yeah, you know, when in the issues, everything is self-service, so you can post whatever you want. You can include attachments, you can include pictures and JavaScript and all that. On our HackerOne bug bounty program, we have like too many XSS reports. Some of them are not that good, but yeah, we get many. So we decided to go with content security policy. But we wanted something that was reasonable from a deployment point of view, from an operation point of view. But we don't want to have like 50 security engineers doing their all day coding content security policy and having users complain that, yeah, well, you know, this page is broken down now. I can't do this comment or whatever. So what we're using a letter specification that has introduced the notion of nonces. So I won't give the exact details, but what you do, in fact, you don't have to pre-compute hashes to do so. It's just a server that computes a random number when you include the resource, and only your resources can guess this secret number. So let's say if someone is trying to add an external resource, he doesn't know this nonce, and he cannot. So it's not as secure as hashes, but it's a good balance. So for people interested, you can have a look at those links. Of course, the content security policy at GitLab is not tightened 100% because we don't want to spend our time just with user complaints on it and all that. It's something that maybe is the best balance for you if you want to have some decent security and be able to handle it from an operation point of view. So that's it. So I didn't want to frighten you, but I hope that now you are convinced that malicious front-end libraries, yeah, can be a real issue. You can be a target. This Magic Card group, maybe now it's like 40 companies that have disclosed that have been hacked by this group. So it's a lot. So they're also playing with WordPress and all that, but playing with WordPress is cheating. So I prefer when there's a really hack in the server and they try to do and they do a targeted attack like that. We saw that, yeah. So are there front-end developers here? Yeah. So you should care about security now. So something that maybe people know there, it's really hard for me to find a good book to recommend on the web security model. The Tangle Web is okay from a book, but I would like to have like maybe a book that's 40, 50 pages long and that explain me like, okay, those are those 5 security headers that are important and that explain me, yeah, okay, you can load from facebook.com, but you cannot load from api.facebook.com because whatever. So it's hard and you have to document yourself and you have to play with the developer console to see warnings, to understand what's happening. And yeah, just do it. If you use Firefox, just go in the developer console in any website and you will have fun. You'll see so many errors. Everything is red because people just don't realize that the JavaScript is not working because of those headers. But the website seems to be working, so shouldn't be too bad. So there's solution and content security policy is for me clearly the best of them. But yeah, you have to invest some time to have it working. It's not just setting like a magical flag and then it's going to happen. If your management said, yeah, I want content security policy, you can add one and you can say, well, I trust all the world. It's not going to be useful. Well, you're just going to be part of the 95% of So websites that have CSP on and that are not doing a good job. There are some tools to check if your policy is doing its job. They are not so good today. So yeah, just use the developer console and test. And now I'm open to question and also to feedback on what you do on your daily life to handle it.
First, as a comment, like you can put the CSP in report mode only. So if you're first trying it out, then it's a different error, and then it will still send your errors to the report query, so you can see like what's broken, but your user won't have any impact. It's a great way to test either a new CSP feature or just start
Yeah.
CSP.
You're a developer or you're a security engineer?
Well, I'm a backend developer, but I
Okay, so you're full stack.
And well, my question was mostly like what I've seen in is like when you have npm dependencies, do you have like a suggestion on how to, because some of them can be modified by third parties on npm dark.
Yeah.
We've seen that in this year. So do you have like any solutions or I don't know suggestion on how we could like have a better model for that or?
So at GitLab, well, let's see, there's not like the good solution. Otherwise, yeah, we will not need to talk about it. But we vet the libraries we load, and each time, yeah, we have Robocop on the Gemfab. GitLab is mostly Ruby, so each time a new dependency is included, so we get alerts at the AppSec team, so that we challenge and say, yeah, do we really need this extra dependency? And otherwise, well, we download them and we vet them. It doesn't mean that we read everything, but at least we cache them locally and we don't, let's say each time a GitLab package is built, it's not really downloaded each time from npm or whatever. Or
Do you vet also updates? Because sometimes like someone's
yes,
doing an update with a
yeah. Yeah, so there is no auto update and all that. And I like when I have some time, yeah, to have a look at the diff when the diff is reasonable in size. Yeah. Yes.
So basically, it was an Android attack.
Yeah, it was also because it was an embedded browser with Safari also.
And right, things that you can exploit in WebView that you can't.
So for Android, it depends on the version of Android. So it used to be bad. Now it's rather good. So let's say to make things easy, latest version of Android is like if you are in private mode. So it has in its own life. But it's not as simple because many websites or many mobile applications, yeah, let's say Slack or Facebook or all that, they do the login on a web page and they do it on purpose because they are afraid of phishing attacks. Or let's say you don't know the fake Facebook application, well, you're dead already. But at least they try to avoid that you enter the login credentials in the mobile app. So they use OAuth and they say, yeah, I will redirect you to the official website and you type it there. And because of that, they have to be somehow lax, because most of the time, let's say the login page is not on the same domain. It's not like britishairways.com, and it's going to be login.britishairways.com because they want to set specific cookie to it in it. So because of that, the web view tends to be a bit lax from a security point of view. So in practice, you get the same origin policy in it, but it's, let's say, kiosk mode browser in practice in implementation. So normally you cannot browse somewhere else, but if someone has been able to edit your web page and is loading something from somewhere else, then you're dead. Yeah.
One of the problems with what you do on mobile is any app can register for receiving callbacks from any website. So if you're doing your login inside of WebView, you could have a third party app stealing your
Yeah.
so it's dangerous to do that in general.
Any other question? Well, so if you have and you want to talk, the GitLab booth is just on the left. So feel free to come and talk. If you have questions about GitLab also, we'd be happy to answer on the booth. Thank you.